Uh, Hi, we can finish up this question. Part C here says to construct a 99% confidence interval for the population mean and give us the Greek letter mu. And I've already sketched out a little bit because of the time consideration with the YouTube. Because I like to describe a lot and give more detail than I guess the 10 minutes to typically just walk through the question allow. But the idea is, you see here, um, the edges. You see the edges? I'm going to point with the arrow here. I'll give a red arrow. Over here, or a purple arrow, that'll work, right? Um, it's a 0.5%. And then the other tail, the other side of the distribution, the tail, let's call it a tail, that's more accurate, is a 0.5%. So if we do this sampling distribution of sample means, over and over with replacement and all that, then we're going to expect, based on the appropriate distribution, in this case a t distribution with 11 degrees of freedom, we're going to expect 99%, all things being as expected with assuming normal and all that. We're going to expect 99% are going to be in this interval within 3.106 standard deviations of the mean. But there are going to be some that are going to be way out there. Some of those 12 student samples that are just going to have like several people who don't ever post to the discussion board, like all in 12 group sample. Or you might have in one sample you might have people that post every day, several times a day, or so there might be the outliers on either side, but we're going to catch the middle 99% when that infinite 12 group samples with replacement happens. Let me show you the table where to find this. It's in the textbook, and you can get it through the appendix, but it's the t-table. And it looks like this is the t-distribution, and we're doing a two-tailed test, and just a minute to talk about interpreting the table. I think zoom in a little bit. Okay. Alright, so this t-distribution test, our level of confidence is going to be 0.99. So we're going to be on, alright, we're going to be up here. It's a two-tail test. So alpha, which is 1 minus the level of confidence, is going to be 0.01. So we know we're going to be in the right spot if we look with 11 degrees of freedom and 0.99 level of confidence with so we're going to get this value 3.106. I didn't mean to scribble over it, but that's where that critical value comes from. So that says like the top 0.5% is going to be more than 3.106 standard deviations above the mean on a t-distribution with 11 degrees of freedom. And then similarly, because of the symmetry of the distribution, the bottom 0.5% are going to be less than 3.106 standard deviations below the mean. So just to make sense out of that. So that's useful for us because what we're doing here is we want to find the error amount. And the error amount, let me undo the arrow. Okay, the error is equal to the critical value, which is the number of standard deviations you're going to allow, and times the size of one standard deviation. It's going to be s over square root of n. So whatever that is, and we need to calculate that. So we're going to say 3.106 times s. I think it was 1.12. I want to look. 1.12. And the square root of n, square root of 12. N is 12, right? So that's going to be, I know there's going to be some rounding that's going to happen. And I think this calculator can handle the, okay, good. So there's the square root of 12. And then I want to get the reciprocal of that to get it in the denominator. And then multiply by 1.12. It's a little bit limiting using this calculator. And then, so it might not be natural what I'm doing. Times 3.106. 6. But the idea is we had to calculate the square root of 12 and then get the reciprocal, so it's like 1 over square root 12 and then multiply by, and then, just to get the value. Okay, so it's about 1.004, so let's say it's 1.00. Alright. So the error amount, is well, I'm on the wrong place. Is 1.00. So that's going to be easy arithmetic for us, because what we're going to get is that our sample mean, we're going to add the error to that, and we're going to say that the population mean is going to be in this interval between the sample mean plus the error amount and the sample mean minus the error amount. And that's it's how much room we're allowing it then in that interval. Okay, so that's going to be easy to add and subtract 1 from 2.37. So we're going to get 3.37 and then to subtract 1, we're going to get 1.37.